Hello guys, welcome back. Today's video is the continuation of the previous video that we did, that is mesh analysis part 1. So today's video is mesh analysis part 2, and in this video we'll be discussing about the concept of supermesh and we'll solve a numerical problem. And if you're watching this video for the first time, consider subscribing this channel and don't forget to hit the bell icon. This way you'll get notified whenever we upload any new video. So without wasting any time, let's start right after the intro. So the first question that arises in our mind is, what is a supermesh? A supermesh is formed when two meshes have a current source in common, and that current source can be independent current source or dependent current source. Clear? So a current source should be in common in between two meshes. Clear? Now if we take this circuit for example, then we can see this is a mesh, this is mesh 1, let's say. This is also a mesh, this is also a mesh, right? So let's say this is a mesh 2. Now in between these two meshes we can see that this current source is common over here. This current source is common for these two meshes, so this forms a super mesh, right? So this is a super mesh problem. And what is our super mesh for this circuit? Our super mesh is this A, B, C, D, E and F. A, B, C, D, E, F, A. This is our super mesh. Clear? Now what about this circuit? In this circuit we can see this is mesh 1. Fine. Mesh 1. This is mesh 2. Fine. This is mesh 2. Now we can see that in this circuit as well a current source is there, but this current source is not common in these two meshes, right? This current source is only present for mesh 2. So this is why this is not a super mesh circuit. Clear? So this is a problem of basic mesh analysis. Now let's find out why super mesh. To answer this question, we'll try to solve this question using basic mesh analysis. What the question says? The question says, using mesh analysis you have to find out I1 and I2, that is this mesh currents. Okay, the direction of this mesh currents is already given, so you have to find out this I1 value and I2 value. Clear? Now to solve this circuit we'll be applying the steps of mesh analysis. Step 1 for mesh analysis says identify the number of meshes. So this is our mesh 1, this is our mesh 2. Fine. Now assign mesh currents. Mesh currents are already assigned in clockwise direction, so it's done. Now step 2, write KVL equation at each of n meshes. Fine. Now we have two meshes, so we'll be having two mesh equations, right? Now so applying KVL at this mesh, KVL at mesh 1, 20 is equals to 6 of I1, 20 is equals to 6 of I1 plus 2 within bracket I1 minus I2, because we have already said that while writing KVL for a particular mesh we will consider that particular mesh current to be the largest. Clear? So this is why 2 within bracket I1 minus I2 and the voltage across this 6 ampere current source. Okay, so the voltage will be what? This. So let's say this is V across 6 ampere current source. So this is our equation 1. And what about equation 2? So if we apply KVL at mesh 2, our equation becomes V, voltage across this 6 ampere current source, that is 6A, is equals to 2 within bracket, now it's I2 minus I1, because we are considering for mesh 2, so this is why I2 minus I1, not I1 minus I2, plus 10 of I2 plus 4 of I2, that means 14 of I2. Clear? This is your equation number 2. Now can we find out the value of I1 and I2 by just solving these two equations? No. Why? because we don't know the voltage across this 6 ampere current source, right? We don't know this voltage across this 6 ampere current source. So this is why this question cannot be solved using the basic steps of mesh analysis. Clear? So this is why super mesh problem is different from normal mesh analysis problem. Clear? So in the next slide we'll understand how to solve this super mesh problems. So now we have already done the step 1, that is identify the number of meshes and assign the mesh current. So this step is already done. So now we have two meshes, that is mesh 1 and mesh 2. So this is why we will be having two meshes, that means we'll be having two equations, correct? Now step 2 says write the KVL equation at each of n meshes. So that means for two mesh we'll be having two equations. Now when the question is of super mesh, out of these two equations, one equation will come from by applying KVL at super mesh. That is, we'll be applying KVL at this super mesh. Fine. Another equation will come from by applying KCL at any of the nodes where the current source is present. What current source? Now that current source due to which that mesh problem has become a super mesh problem. Clear? So that means in this question this is the current source due to which this circuit has become super mesh. So this is why we'll be applying KCL at either this node or at this node. Fine. So another equation will come from by applying KCL at, let's say, ground node. For this question we are taking this node, right? So now from applying KVL at super mesh, so our equation will be 20 is equals to 6I1 plus 10 of I2 plus 4 of I2, that means 14 of I2 in total. So that becomes your equation 1. Am I clear? Now another equation will come from by applying KCL at this node. So by applying KCL at ground node. So if we apply KCL at this node, we can say this is I2, in this direction I2 is flowing, in this direction I1 is flowing, right? So if we apply KCL at this node, incoming current is equals to outgoing current. So incoming current is what? Only I2, and outgoing current is equals to I1 and 6 amperes. So our equation will be I2 is equals to I1 plus 6. That means I2 minus I1 is equals to 6. This is our equation 2. Clear? So our equations are what? Equation number 1 is 20 is equals to 6 of I1 plus 14 of I2, that is our equation 1, and equation 2 is what? Equation 2 is I minus of I1 plus I2 is equals to 6. Clear? Now if we multiply this equation 2 with 6, so multiplying equation number 2 with 6, that becomes our equation number 3. So our equation number 3 becomes minus of 6I1 plus of 6I2 is equals to 36. That is our equation number 3. Now if we just add equation 1 and equation 3, so adding equation 1 and equation 3, equation 1 is 6I1 plus 14 of I2 is equals to 20, and equation number 3 becomes minus of 6I1 plus of 6I2 is equals to 36. So what we got? 20 of I2 is equals to 56. So I2 becomes what? 56 by 20, that means 2.8 amps. That means our assumption is correct. for direction of I2. That means that what direction we have assumed for I2 is actually correct. Clear? Now if we just put this value of I2 in, let's say, equation number 2, we'll get the value of I1. So I1 becomes I2 minus 6, that means 2.8 minus 6, that is equals to minus of 3.2 amps. Now since we got this minus, so this is why our assumption for direction of I1 is wrong. Actual direction is opposite to what we assumed. Clear? So that's your answer. So the final circuit is what? So the direction of I1 and I2 that was given in the question is this, that is in the clockwise direction, right? But what answer we got is I1 is equals to minus of 3.2 amps and I2 is equals to 2.8 amps. That means I2 is flowing in this direction only, that is 2.8 amps is flowing in this direction only, that is clockwise, but I1 is flowing anti-clockwise. Clear? This is wrong direction, so I1 is flowing in this direction, that is 3.2 amps. Clear? This is counterclockwise and this is clockwise. This is counterclockwise, CCW, and this is clockwise, CW. Clear? So that's your answer, right? Now if I ask you what is the current flowing in this 2 ohm resistor, that is what is the current flowing in this 2 ohm resistor, how will you find out? Very easy. You just apply KCL at this node. What will you get is that, let's say the current that is flowing in through this 2 ohm resistor is I. Okay, let's say it is I. So by applying KCL, I is equals to, because this is the incoming current and these two are the outgoing current, so incoming current I is equals to 3.2 plus 2.8, that means 6 amps. Clear? So this is the process 1. You can find the value of current that is flowing through this 2 ohm resistor in this way, that is by applying KCL. Or if you look closely in this branch, you can easily see that this 6 ampere current is flowing through this branch by just looking at this circuit, right? So you can easily say that the current that is flowing through this 2 ohm resistor is 6 amps. Fine? Hope you understand that. Now this question is for your assignment. What is the question? The question says, using mesh analysis you have to find out I1, I2 and I3. Okay? So in this question you have 3 mesh, mesh 1, mesh 2 and mesh 3, right? So 3 mesh, we just giving a hint, 3 mesh means 3 equations. So that means 1, 2, 3. Out of this, one equation will come from by applying KVL at this supermesh. Clear? Another equation will come from by applying KCL at this ground node, and another equation will come from by applying KVL at this mesh. Clear? So do it, and after 24 hours I'll be writing down the correct answer for this question in the comments, so you can check over there. And this is the end part of this video. Thanks for watching. See you in the next video.